Let us discover the best way of finding the exact value of inverse trigonometric ratios with 8 examples. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll see how do we find exact value of inverse trigonometric ratios. Many students are confused about it, and I hope this video will help answer all their questions. Here is a brilliant approach on solving such problems. With set of 8 questions, I am going to answer all your problems. So the questions read like this: arc sine half or sine inverse of half. Two different ways of writing the same thing. Writing arc sine half or sine inverse of half means the same thing. We really want to find the angle for which sine value is half. That is what it means. Question 2 is arc cosine of square root 2 over 2 or cos inverse of 1 over square root 2. Now square root 2 over 2 can also be written as 1 over square root 2. So many times when not rationalized, the problem may have 1 over square root 2. Arc tan square root 3 or tan inverse square root 3. Then we have the negative values. Arc sine negative square root 3 by 2, arc cosine negative half, arc tan negative 1. And then in question number 7 and 8, once you understand the above strategies, you will be in a position to also find the exact value with composition of inverse functions. Arc sine tan 3 pi by 4 and arc cos 5 pi by 4 are two examples which we are going to discuss. So first let us try to answer the first three questions where all the three values given to us are positive, right? And then the next three, all three negative. And then the two with composition. Perfect. Well, in case you want to learn from me directly, you can always send an email to globalmathinstitute@gmail.com. Our students are right there on the top. It is for a reason. They understand and they have confidence. Great. Now, while we solve these questions, arc sine, arc cosine, or tan inverse, you may also like to look at my lesson on inverse trigonometric ratios to get your foundations right. We'll give you concepts as we move along. Now, as you know, sine is a periodic function. Inverse of the sine is only defined when we are working in quadrant 4 and quadrant 1, right? So this is the area where sine inverse is defined. So we take it from minus pi by 2 to plus pi by 2, right? So this area, correct? When we talk about cosine is defined inverse function between 0 to pi. So that is the inverse function graph, as you can see, and the interval 0 to pi in which it is defined. So the value of cosine goes from positive 1 to negative 1, always decreasing. Sine is always increasing. For tangent function, we'll see how it is defined when it comes to that. Well, let me tell you, it is also defined within minus pi by 2 to plus pi by 2. Now, to find the matching angles for the given values, we are going to use unit circle as shown here for all our examples. In the playlist, you'll find many of my videos where we have used special triangles for the exact values. Clear? So let's move on to the very first question and understand the approach. So here we'll find the value of arc sine half or sine inverse of half. As you know, sine inverse of half, we are looking at quadrant 1, right? It is positive in quadrant 1, correct? So in the unit circle, you can look for the y value where it is half, right? So that gives you the angle, correct? So this is pi by 6, and directly you can write this value as equal to pi by 6. In case you are working in radius, well, if you are working in degrees, pi by 6 will be 30 degrees, right? So either one of them is your solution. So see, sine inverse is only defined between minus pi by 2 to plus pi by 2, correct? And we get all the values from negative 1 to positive 1. Makes sense, right? So reading directly from the circle helps to answer the question. So I hope you've understood, right? See, I've taken the right half of the unit circle. You'll also see that the angles clockwise are positive, counterclockwise are positive, and clockwise are negative. Now let's move on to question number 2, where we have the value of cos inverse of 1 over square root 2 or r cosine square root 2 over 2. Well, whenever we talk about square root 2 over 2, then we are looking into the special triangle, which is pi by 4, right? So in pi by 4, we know the sides are 1, 1 and square root 2, correct? Or if you're working in degrees, 45 degrees. Since cosine is positive, we are looking for quadrant 1. As you know, the range of all the numbers fall within the domain from 0 to pi. So 1 over square root 2 from the unit circle clearly is this line, correct? Where you get the value, which is pi by 4. So the answer here is pi by 4 in radians or 45 degrees in degrees. Makes sense, right? So reading easy, right, from the graph. But we are looking into this graph from 0 to 180 degrees when we are working on cosine. Is that clear to you? Correct. Third question, tangent function. We need to find tan of square root or tan of square root 3 or tan inverse of square root 3. This reminds you of a special triangle which is 30, 60, 90 or pi by 6, pi by 3, pi by 2, right? Sides being 1 to square root 3. Since tan ratio is opposite over adjacent side, the angle will be pi by 3. So from special triangles, it is very easy. You can see pi by 3, which is 60 degrees, correct? And from the unit circle, you can again read the value. We are looking for tan, right? So tan is a ratio of sine over cosine, right? Tan is a ratio of sine over cosine. So you see tan theta is sine theta over cos theta. So that means the y value over the x value, correct, should be square root 3. So that means we are looking for this particular value. Do you understand? And the angle, as you can see, is 60 degrees. Makes sense? So for tan, you have to actually divide the y coordinate value with the x coordinate value to get the answer, right? Here you see the graph of tan. It is defined between minus pi by 2 to plus pi by 2, correct? Okay, so we have done the first set of questions in which all the values taken were positive, correct? Now we'll look into the negative values in our second set of 3 questions, correct? Here is question number 4. Once again, a good reminder, in case you want to learn from me directly, feel free to send an email on globalmathinstitute@gmail.com. Let me also thank all the viewers and subscribers for watching my videos and posting excellent comments. You can also donate. We are providing free services for last 15 years with more than 17,000 videos being watched over 80 countries. quality education is not available everywhere, right? With our videos, students in remote areas are able to access quality education. You can support for that. Okay, great. Now let's look into the questions where we're looking into arc sine of minus square root 3 by 2. Negative value, right? So let's look into this particular unit circle, only the right half of the unit circle, correct? Negative square root 3 by 2 should be the y value. You see that? So that gives you the angle, and this is the solution, which is, you can read, which is because you're moving in this direction, which is clockwise. So the answer here will be equal to minus pi by 6, pi by 3, correct? 60 degrees or minus 60 degrees. Does make sense? Clockwise. And you are in quadrant 4. So even by applying the cast rule, you understand sine is negative in quadrant 3 and 4. Now, since inverse is only defined in these two quadrants, our solution will be from minus pi by 2 to plus pi by 2. So, we will not write going all the way counterclockwise, right? We'll write minus 60 or minus pi by 3 as our answer. Is that clear to you, right? Easy. Question number 4, let's look into the cosine value. Again, we are looking for something in quadrant 2 because in quadrant 2, apply the cast rule, right? In quadrant 2, only sine is positive, cosine is negative. So we are looking for x value in a unit circle being minus half, right? So if you see, this is the x value in unit circle being minus half, and that's the value, right? So you can read it is 2 pi by 3. So we get this value as 2 pi by 3 from the unit circle directly, correct? Or you can also write this as 120 degrees. Is that clear to you? So it is that simple. Just reading directly from the unit circle. You could also make a special triangle to answer this question, correct? Special triangle will be looking something like this. 1, 2 square root 3. For cosine being half, we're looking at this angle, which is pi by 3. However, you are in quadrant 2, and therefore the solution is related acute angle of pi by 3, right? So this is pi by 3. The reference angle will be 2 pi by 3, which is your answer. You get the idea? Pi minus pi by 3. That is how you are going to answer the question using special triangles. Correct. Now here's the sixth question on the negative values. We are now looking into arc tan minus 1. Means we are looking into quadrant 4, right? So the solution lies in quadrant 4. So minus 1 means the value of sine and cosine exactly same, 45 degrees negative, right? So the answer will be equal to minus 45 degrees, or you can write minus pi by 4, correct? On the unit circle, there you go, right? These are the exactly same values for sine and cosine. Therefore, their ratio will be 1. Negative because sine is negative. Perfect. So with that, we have seen simple problems where direct reading from the graph helped us. Now we are looking into two composite functions. Here, we'll actually learn a lot more. So, once again, if you want to learn from me directly, feel free to send an email. Our students are right there on the top. We can really help you in getting excellent marks or admission to the best universities. Right. So, let's look into question number 7, which is arc sine tan of 3 pi by 4. Now, when we are looking into composite functions, it is a good idea to look at the circle as a whole, right? Rather than the only half which is relevant for the inverse function. Is that clear to you? So, tan 3 pi by 4, we are in which quadrant, right? So, basically, tan 3 pi by 4 means 1 pi by 4, 2 pi by 4, 3 pi by 4. So, there we are in quadrant 2, right? So, we are in quadrant 2. So for tan 3 pi by 4, we are working on this, correct? So in quadrant 2, the value is going to be negative. We can use special triangle also, 3 pi by 4, and the related acute angle being pi by 4, right? So look into this special triangle, and we know we are in this particular position, correct? This is for pi by 4, correct? So the related acute angle here is pi by 4, and we want the value for 3 pi by 4. So of course it is negative, right? So we'll write arc sine -1. You get the idea. So evaluate the inside of the composite function, which is normal trigonometry, right? Now we come to the sine inverse of -1. So -1 is the y value negative along this line, correct? Which in our case is minus pi by 2, correct? Then you have to look into this circle. You get the idea? The half of the circle. And therefore, arc sine of this will be minus pi by 2. Or you could write minus 90 degrees. Does make sense to you? That is how you can work with the composite functions when inverse are combined with the other trigonometric functions, correct? So sine with tan we just saw. Now let's look into the last question, which is cos or arc cos of cos pi 5 pi by 4. Normally, if you do inverse of a function with itself, you normally get the value of the x value. But here, let's see what do we get. Now, cos 5 pi by 4 means you are actually in which quadrant, right? 1 pi by 4, 2, 3, 4, and 5 pi by 4. This is 5 pi by 4, correct? So from here, you can read the value of cosine. So we can rewrite this as arc cos of cos 5 pi by 4 is a negative value, correct? So, and it is equal to negative square root 2 over 2, correct? Now, arc cos of negative means you are only going to look into this side, correct? Because cos inverse is defined between 0 to 2 pi, 0 to pi, right? So from 0 to pi. Now, where is this minus square root 2 by 2? As you can see, it is right there, right? So this value, which is 3 pi by 4, right? So this is equal to 3 pi by 4. As you can clearly see, the answer is not 5 pi by 4. It is 3 pi by 4 or 90 plus 45, which is 135 degrees. Is that clear to you? So inverse arc cos of cos theta is not theta in this case, mainly because 5 pi by 4 was out of domain. Do you see that? 5 pi by 4 was somewhere here, whereas the domain for the inverse function was between 0 to pi, correct? So I hope with that you have understood the concepts and we have solved or provided you the solutions for all these questions. Perfect. Feel free to write a comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.